2.
Hi again. We're now on Friday, 4/17/20, going into the future fast. And we started integration last time, and integration is going to have a worksheet, which I sent you an email on, and it's worksheet chapters 12-13 in your shared class folder. And you'll be getting you'll have notes by now in your shared class folder on chapter 12. For the first homework assignment, 12.1, it'll be problem 1, A to L. Those are all integration problems. And 2 to 7 are your practical problems. As I mentioned in the email, I would prefer to have all of chapter 12 handed in one package and all of chapter 13 problems handed in one package, but this will give you a good idea of when to do them. So after class today, you could do these. All right, so from the last class, I gave you a you-do problem. And here we have that the f prime, the derivative actually, is 5x fourth minus 9x third plus 3. Find the original function. So the first step is to make this into a true derivative. Multiply both sides by dx. And now we're going to distribute the dx. And since we have 3 terms on the right, we're going to integrate them each individually. You can put the sign outside the integral. And we're going to use the power rule up there, which says that if I'm given a differential df and I have the integral of ax to the n dx, the f term, which is a function, is ax n plus 1 power divided by n plus 1 plus a constant. So here we'll have a equals 5. Let's make that into a real 5. I don't know what that means. So a is 5 and n is 4. Here a is 9 and n is 3. Here a is 3. And there is no x. We have the integral 3 dx. We'll have to work on that. We'll put a question mark on here right now. Okay, so let's work on the first 2 terms first using the power rule. Let's just erase this. So we're going to get f equals 5 x to the 4 plus 1 over 4 plus 1 plus, that's a minus, keep the minus sign, minus 9 x to the 3 plus 1 over 3 plus 1. And now we have plus. Now remember I said before we had a special case where the integral of df was equal to f, right? Well, what if we have the integral of 2 times df? Well, that's going to equal to 2f. Because what I can do is always take the 2 outside the integral because it's a constant. So I can actually write this as 2 integral df, and that would be 2f. So therefore, 3 integral dx is just going to simply be 3 plus c. And that is my integral. Let's clean it up. 5 x to the 5th over 5 minus 9 x to the 4th over 4 plus 3 plus c, and the final one, 5's canceled, x to the 5th minus 9/4, x to the 4th plus 3 plus c.
Question, Dr. Mirabile.
Yeah.
Isn't it 3x?
Yeah, it's 3x. What did I do?
You just put 3 plus c.
Oh, yeah, no, it's supposed to be, it was 2f, yeah. Sorry, thank you very much. I don't know how I just got the 3 in there.
Because it's like x to the
Oh, yeah,
0.
no, it's 2. So if this was 2 integral dx, that would be 2x.
Right.
Just, okay, so 3x, thank you.
Because the power rule still works. It's just x,
Yeah.
you start with
No.
x to the 0 power.
Yeah, you start with x to the 0 power. That's what you do. I tried to do that before, and so just give them a rule. Just follow these rules. That's a special rule. That's the general rule. Okay, so any integral of a differential by a multiplied by a constant is just the same thing. Here, 2 integral dx is 2x. 2 integral df is 2f. Same thing. Just like the integral df was f. Okay, so that's your answer. So let's do another one. And you will have a number of them to do on your homework. I'll give you another one as example 5. And I'm going to say, well, let's make it y prime now. Equals 2 over x squared plus 3 over the cube root of x to the 5th. Now, what do? We know that we cannot use square roots in our problems. So you remember the rule? If I have a function in the root raised to a power and the bth root, I could write that x a over b. So let me rewrite these. Before we do anything, we rewrite it. So x is going to be, a is 5, b is 3. 5/3. Now once again, when we have things, there is no quotient rule in integration, so we have to bring everything up onto the numerator to satisfy that. So y prime x is going to be 2 times x to the minus 2. Let me write that better than that. Plus 3 x to the minus 5/3. Now we want to write this as a regular differential. Multiply out by dx. And distribute. And put the integral sign on each term. So now we have to integrate that term. We have 2 terms here.
Is it dy over here?
That's a dy, right? Thank you. Sometimes my x's, I don't finish the tail on, or the, what is that, the tail, yeah. Okay. So my y's and x's look the same. So here we have n is 2, n is minus 2, a is 2, here n equals minus 5/3, and a equals 3. So substituting for each term, we're going to get y equals 2 x minus 2 plus 1 plus 3 x minus 5/3 plus 1 plus c, and this becomes 2 over minus 3 x to the minus 1 plus, now the easiest way to do this is to do this, I'll do another step for you, is x to the minus 5/3 plus, what's 1? 3 over 3, right? Over minus 5/3 plus 3 over 3. So what this becomes is minus 2/3 x to the minus 1. And you got minus 5/3 plus 3 is going to be minus 2/3. X to the minus 2/3 minus 2/3 plus c. And at long last we get minus 2/3 x to the minus 1. Now we're going to have 3 times minus 3 over 2. I'll write that out for you. I'm going to flip it. X to the minus 2/3 plus c. And finally, we're going to get minus 2/3 x to the minus 1. That's going to be minus 9/2 x to the minus 2/3 plus c. Now that was a complicated one. When you do something like this, you might want to check it. So how do you check it? So a check would be, this is at y of x. Check would be is to take the derivative. That's a bad check. So sometimes I've written bad checks. But you guys probably have never written checks in your life, right? So what was the original function here? Well, let's write down the original function first. What did I have originally? Well, I'll put it down here. I had x prime x equals, what do I have? 2x to the minus 2. And I had plus 3 minus 5/3, right? That's, well, the original problem really looked like this. 2 over x squared plus 3 over x to the 5/3. And it really started out like this. Plus 3 over the root. So let's see if I can at least get back to here. So, does it look like we're going to even get back to here? Let's see if we did. Well, now look. Now, I purposely did this. Okay, this was not one that I actually did. When I make a mistake, I will. What did I do here that was wrong? What's minus 2 plus 1? Should be the same thing as over here, right? So this should be minus 1. How did I know that I made a mistake? When I take the derivative of this, I get what? I get plus 2/3, right? X to the minus 2. What about here? What's 2/3 minus 2/3 times minus 9? Okay, the 2's are going to cancel. It's going to be minus 3 x to the what? Minus 2/3 minus 1, right? Which is, what did I start out with? Minus 5/3.
I got 10 seconds on this.
So it looks like I got this one right, but I got that wrong. So let's go back and check. Minus 2 plus 1 should have been minus 1. There it is.